Alright, so today I'm going to be talking a little bit about electronics and what's going to make an airplane fly. And this is going to be for the beginner, really, who doesn't know a whole lot about RC flying. And so here we go. So first we're going to start off with motors. Motors, whether they're electric or gas, well, an electric motor is going to be fairly small. You know, this is it in my hand, and this is it compared to a DX7. It's fairly small. They range up in size and they go down. And there's brushless, which have 3 wires, and brushed, which only have 2. This one got cut off. I got to solder that back on. And whether you have a brushed or brushless motor, you're going to need a speed control. This is a Grayson Hobby 18 amp speed control. Programmable. You really don't need to program these. I've never had to, unless you buy it as an airplane ESC, or and you want to use it as a helicopter ESC. You're gonna have to change that. But the ESC, it's gonna regulate the power to the motor and to your servos and to your receiver and whatever else you might have on your airplane. And these have built-in BECs. I believe they're 5 amp BECs. Correct me if I'm wrong. Most do. Some have 2 amp BECs. But you might, if you have a very high class one, like a lot of Castle Creations, you're going to need a separate BEC. I really don't know a whole lot about BECs, so you're going to have to figure that out off the internet. But how electric motors work is there's some magnets in there, those little blocks right there, and those constantly are changing from positive to negative as electricity is run through them, and that's what's going to make the motor spin. Push, pull, push, pull, push, pull, push, pull, push, pull, and it's going to do that very rapidly. Same thing with a brushed motor. Now, a brushed motor only has 2 wires, and I forgot to mention, this is a brushless outrunner motor, which the whole outer case spins. An in-runner motor is the opposite. Only this spins. The shaft spins. Most brush motors are going to be geared same as an in-runner motor. They're going to have to be geared to the shaft. You're going to need a gearbox with gears and your pinions and everything, all that good stuff. But I tend to stray away from those because they're very easy to break in a crash. So now let's go over servos. Now, as you can see, I've got 2 different servos here. This is a 9 grams. No, this is actually 11 grams, I think. But S3 114 Futaba servo. They're very good servos. I only have 2 of them right now, but I've used them a lot, and they're very good little servos. Okay, these are, I think, micro servos. I'm not exactly sure. So this would be one end of the spectrum. This is the largest servo. These are standard servos. And this here. Okay, so we've got this compared next to my DX7, and we've got this compared to my DX7, and compared to this battery, and compared to this battery. You're going to get more torque per ounce with this, but they're designed for a lot larger airplanes. Now you're going to see that this says digital, and basically digital servos are going to pull more energy, but they're going to be quicker to respond to stick movements. That's the downside versus the upside. You really don't need digital servos unless you're flying very fast airplanes, very maneuverable airplanes, or same with a helicopter. And a lot of helicopters need digital tail servos. Tail servo, I'm just going to use this as an example, even though it does not have a tail. A helicopter that is geared or belt driven is you're going to have your thing right here, and there's going to be something that goes down to the tail, and then there's going to be a belt right here. A servo is going to move the pitch. It's going to adjust the pitch of this, and that's going to make it yaw left or right. And a helicopter would need a gyro as well as a servo for that, but that'll be in a different video. And then, so that's about it about servos. Oh, except metal gear versus plastic gear, or normal or nylon gears. Nylon gears tend to strip a little easier on helicopters. That's a little bit more of a problem. I've never had a problem with stripping a servo gear, but definitely look into that if you're flying. And if you're flying more high-powered airplanes, spend the extra money and get the digital Metal Gear servos. And in fact, speaking of digital Metal Gear servos, this aircraft has digital Metal Gear servos, and I'll show those to you. These are really flat servos, but digital Metal Gear servos. These are actually Metal Gear, even though it doesn't say it in Metal Gear. You have to look on the website. I think those are like $61 servos. They range in price incredibly. I think that small one over there that I showed you guys was $13. And then the HS55s are really popular. They're only like $10. But and then that one over there is like 60 something bucks, the servos. So let's talk about batteries now. Batteries range from 2200 milliamps, 3-cell LiPos. And here's a 2100, and here's a nickel metal battery out of my airsoft gun. So this is 1515 milliamps. I'm sorry, 1150 milliamps at 8.4 volts, and this is fairly heavy for an airplane battery. That's why it's in my airsoft gun. This is lighter, and it has 11 volts. So you're going to get more power out of this, and you're going to get a longer flight time because it's 2100 milliamps. Here's the smallest one. Here's the other end of the spectrum, really. They get even smaller than this. This is a 2-cell 800 milliamp. So, ding, right there, and then right there. But you want to go with the LiPos generally, but you want to be very careful about charging them, because they have a reputation for being somewhat explosive. I don't have a charging bag, only because I've just never had one explode on me. However, I'm getting one, and this would be the charge lead. That's a 2-cell charge lead. Note the 3 plugs is a 3-cell charge lead. Note the 4 plugs. All right, now what's next? Receivers and transmitters. Receivers are a little thing on the airplane that is going to receive the signal. It's going to receive input from your transmitter. And these ports right here are your servo ports. So you're going to plug a servo into there, and the servo is going to move the control surface, and that's going to deflect air, and then that's going to move the airplane. So basically this is going to receive a signal from this to move that. Very simply put. This is a DX7. It is a really high-end radio. I think the DX8 just came out, but I wanted a DX7 because I really didn't need all those fancy features. And preferably, I don't like looking down at my transmitter trying to stare at telemetry and then end up crashing my plane. That's not exactly a fun day for me. So I went with the DX7. It's got plenty of features, 7 channels. You really don't need that if you're a beginner. It's got a 20 model memory, an LCD screen. Can't really see that too well. LCD screen, got my CX3 on there, and so far I've only got 1, 2, 3, 4, 5 planes programmed on there. So all in all, I think this was knocked down from 350 to 300 at my local hobby shop, but and that comes with 4 of those giant servos. Okay. Comes with an AR7000 receiver and a satellite receiver. That's the satellite receiver. I need to tape that back down. And the receiver's right there. And also comes with oh, excuse me. Also comes with, you know, I can't seem to see it, but it's I can't seem to find it. But it's a little switchy thing, and it's nothing really. It's not too terribly important. But and then it comes with a flight battery for if you're not a LiPo battery, but it comes with a small nickel metal battery for if you're flying gas airplanes. And I think that's upstairs or something. No, whatever. But thank you for watching this beginner episode, and that'll teach you should teach you about the electronics that are on electric airplanes, and what I'm flying with, and what a fair amount of other electric flyers are flying with. Thank you for watching, and tune in next time, and goodbye.